have numbers and we have some operations on them. Imagine we have this kind of numbers, and operations are choose some subarray, like this for example, then pick the minimum value and this array, and you can remove all the instances of this value to 0, and repeat this process until you have all the array 0. And answer is the minimum operations. We have to do this optimally. So how can we do it? Let's observe what kind of situations we can have. Like in this one, this part of array grows, this part of array decreases, and intuitively I want to choose all this subarray because it has minimum here and here, and we can minify both those ones to 0. And the other values are like this. Then I want again to pick this subarray. I can't pick all the array again, because if I do this, this 0 would be the minimum, and I want this 2 be the minimum instead. So I pick this subarray, I do 0 find operation, and I have the final just number 3 to become 0. It's this kind of situation where half of the array is increasing, then it's decreasing. Let's observe some other situations, like if first half is decreasing and the second half is increasing, then first I pick all the array, and the minimum is just the number 1 in the middle. The next is more interesting, because in this situation I have two subarrays, because if I choose all the array, the number 0 would be pointless to choose because it's already 0. So I have to choose this prefix and this suffix instead. So I can't do any better, just choose that, and I do this operation and this operation. They are separate 2 operations plus 2 operations. Then I have this situation where just number 3s, and again I have to choose them separately, plus 2 operations. Okay, if we look at the description of this problem, we see that the length of the array is 10 to the power 5. So this problem is kind of big, and they're asking us to find O of n, or n log n would be acceptable solution. So let's see if we can find the O of n solution. To find the O of n solution, you have to think like you already know this solution, and O of n means that you just go step by step at each position, and you can't do any other, like for example, you can't for this position try to pick different ends of subarrays. So you have to consider you already visiting it only only once or some constant time. So let's just try to move this from step by step from first position. In the first position, we know that we visit the number 3. So let's put it like in our little memory and move next. Now we see the number 2, and what we can observe, what intuition we can derive from this 2. The 2 is less than 3. That means if we choose any subarray, we have to pick the number 2. And that means that the number 3 will be a separate operation. 3 is separate. Operation. Let's do this kind of dividing this number of operations. So for the number 3, if we visit the number 2, we have to pull the number 3 from our memory and increase the number of operations. Next, we visit the number 1, and the situation repeats. It's less than 2 when we pull the number 2 from our little memory and we increase the number of operations. Then we visit the number 2, and what can we say? That we have in our memory numbers 1 and 2. That's all, because if we have any subarrays, like starting from number 1 or starting from number 2, we have to choose the minimum of 1, and so I drawn it wrong. So if we have like this subarray or this subarray, we still have to pick the number 1 as a minimum. So we keep it, and we keep the number 2 until we visit the number 3. So we visit number 3, and what we see that the number 3 is bigger, and we still have to pick the number 1 as a separate operation. So let's put the 3 into our memory, and then we finish our array, and we have this kind of numbers. And that looks like I don't know, we have to pick 3 separate operations for the 1, then for the 2, and then for the 3. It just will be plus 3. So this intuition is kind of works. You can check this on any other combinations of like grow, then decrease, then again grow, or like this. It would be working solution. So what does it tell us? That our intuition is we keep the numbers as they are increasing, keep, and this, if they're decreasing, we pull them from our memory and increase the number of operations. How much we should pull? We should pull until we, so keeping this 1, 2, 3, then we meet the number 2, we have to pull the number 3 because it's bigger, and in this situation it has to be a separate operation. The number 3 will be a separate kind of removal. So this is a solution for, it's called a monotonic stack or monotonic queue. It's just kind of pattern. You have to keep the numbers and you have to remove the numbers if they are bigger. So it's decreasing stack. Every number in this stack would be in increasing order, like 1, 2, 3 we keep, and if we met the number that is less, we pull the last number 3 and keep the number 2. That's it, I solved it in 11 minutes. Let's look at the hints, maybe there are better solutions. This is interesting because I didn't understand the hints. For each target value. Okay, okay, they are using this kind of condition as to iterate over all the values, not over the numbers in the array, the iterating over values. Then for each they want a maximum segments this kind of brute force solution. I don't understand what the hint is about. Let's look some other. Okay, this kind of hash map. Okay, they used this, then sorted by k, and then what? Okay, my solution is a monotonic stack, and it has off and time complexity and all off and space complexity, because we're keeping this stack and all the array theoretically can be in the stack. And this solution is kind of worse, but it has n log n. As I see, they used reset and sort by, and it's kind of much harder to comprehend. Also, my solution is 44 milliseconds, but this can be from just unfortunate. Okay, that's it.